Good day and welcome back to my channel. Today we will be looking at part 2 of short differentiation. In order to do more complex short differentiation problems, we need to do some preparation. We need to ensure there are no brackets in the equation, that there is no long division lines. We get rid of long division lines by either separating the terms by giving each numerator its own denominator, or by factorizing so that we get rid of the long division line. We also need no surds over the variables we're differentiating, and we need no variables that we're differentiating as denominators. After we do the preparation, it's time to differentiate. The first thing we do is we change our notation to the differential notation. Thereafter, we use the 4 rules that we learned in the previous video, the 4 rules of short differentiation. After we do the derivative, it might be necessary that we need to neaten up and ensure that there are no negative exponents, no fraction exponents, and we need to simplify surds. I will strongly advise you to look at your laws of exponents and surds before progressing here, as you will need that to understand what's being done. Now, let's look at an example. It's very important to know these preparation steps, but for this first example, I'll put it alongside. We'll use this preparation steps as a checklist before we do the derivative. Right. So the first thing is our equation must have no brackets, which is fine. No long division lines, has no long division lines. Surds over variables you're differentiating. There's no surds over the variable we're differentiating. And lastly, no variables you're differentiating as denominators. Now that's a bit of a problem because our x is the denominator. But according to our laws of exponents, we can bring the x to the numerator as long as we change the sign of the exponent. So let's do that quickly. So y is equals to 2 over 3 x to the power negative 4. So I brought it to the numerator, but I changed the sign of the exponent. Now all of our preparation steps are complete, and now we can perform the actual derivative. Now this identifies as the third rule of differentiation, which is the power rule. So we take the exponent and we multiply it by the coefficient and we subtract 1 from the exponent. Now in this step, when we're doing the derivative, we now change our notation. So it becomes y prime is equals to minus 4 times 2 over 3 is minus 8 over 3, and then we remove 1 from the exponent of the x. So it becomes x to the power negative 5. Now our derivative is complete, but we can neaten it up a bit by making our exponent positive. So this simplifies to y prime is equals to minus 8 divided by 3x to the power 5. And our derivative is complete. Please check out our Instagram page if you would like to register for ACE Academics tuition. Now let's look at a second example. We have f of x is equals to the cube root of x squared minus x to the power half, all divided by the square root of x. There's no brackets in our equation. There is, however, long division lines. So let's separate it out and give each numerator its own denominator. So it's f of x is equals to the cube root of x squared, all divided by the square root of x, minus x to the power half, all divided by the square root of x. Right, now we got rid of our long division line. The next step is no surds over variables you are differentiating. And that's a problem because we have surds over almost all the x's here. But according to our laws of exponents and laws of surds, we're able to change our surd into an exponent. So this becomes f of x equals to, now the cube root of x squared simply becomes x to the power 2 over 3, all divided by x to the power. Now the square root of x becomes 1 x to the power 1 over 2. If you notice, the power of the x becomes the numerator in the fraction, and the root power becomes the denominator in the fraction. If you do the same for the next term, it's x to the power half, all divided by x to the power half. And as we see, it's the same term here, so they can cancel out and just become 1. Now let's go further in the preparation. No variables you're differentiating as denominators. And this is a problem in this step here, because we have x's as denominators. So let's get rid of that. So f of x is equals to... Now, when we're dividing and we have the same bases, we can subtract the exponents as per the laws of exponents. So this becomes x to the power 2 over 3 minus a half. Minus 1, because these two terms cancel out and we just get 1. Right, so we're left with f of x is equals to x to the power 1 over 6 minus 1. And all our preparation steps are complete. Now we can do the derivative. The first thing is to change the notation into the derivative notation. F prime of x is equals to... The first term is the power rule. So we take the exponent and we multiply it by the coefficient. So it's 1 times 1 over 6, which is just 1 over 6. And then we subtract 1 from the exponent of the x. So 1 over 6 minus 1 is negative 5 over 6. Now the derivative of minus 1 is just 0. Because the derivative of a constant is 0. Now our derivative is complete. And all we need to do is neaten up. So f prime of x is equals to... Now we can take the x to the denominator and we can make the sign of the exponent positive. So it simplifies to 1 over 6 x to the 5 over 6. But we can go one step further and we can make sure there's no fraction exponents by changing the x to the power 5 over 6 to a third. Let's do that in the final step. So we have f prime of x is equals to 1 divided by 6. Now, if you recall, the numerator in the fraction was the actual power of the x, and the denominator was the root. So, x to the power 5 over 6 is the same thing as the 6th root of x to the power 5. And our derivative is complete. Now, I have an exercise for you guys to complete. Please try it out to see how much you've learned in this video. If you enjoyed this video, please give it a thumbs up and subscribe to our channel. Also, don't forget to follow us on Instagram at ace.academics.tuition.